Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afan Yusof. My matrix number is CE190029, and I'm with two of my group member, which is Cempaka Amalin binti Mahazi and Hanif Hakimi bin Azlan. So each of us have been given tasks when Cempaka Amalin is given task to doing activity number 3, which is answer the question, and Anewakimi is giving task is doing the introduction and help me with the activity number 1, number 2, and the observation. So the introduction of why we doing this lab is to study the basic construction of AC single phase and to pole synchronous motor. We proceed to the activity number 1. So this is activity number 1. As you can see here, I will explain a little bit about the connection. And this is a universal power supply, and this is DC volt and DC emitter. This is a AC emitter and voltmeter, and this is a AC DC power supply. So this is AC single phase, DC variable speed. DC variable speed, and this is a stator which a brush, and this is the row. So the function of the carbon brushes is to transport the current into a rotor and act as a mechanical commutator to convert the one rotor winding AC to DC. So this is AC phase synchronous motor set up for the connection. So I will proceed to the how it works. So first of all, to start the motor, switch on the drive machine first. Bring the shaft speed to 3000 because their formula speed is 120 times frequency divided by number of poles, which is 50 hertz and 2 poles, and we get 3000 RPM. So then switch on the AC single phase supply to the stator winding and adjust the voltage level to 125 volt. And then we switch on the synchronous motor rotor DC supply and adjust the current to 2.5 DC emitter. So the motor should pull into synchronous and run steadily at its synchronous speed. Then we switch off the drive machine, but we know that the shaft remains coupled, so to the synchronous motor, and it will drive by it, so it keep rotating when we switch off the drive machine. So after that, we have to take a reading to this no load test and record it. So this is a table that we have been set up. Says the voltmeter is set up by 135 volt, and we get from the experiment is 0.6 emitter. For rotor, we have been set up for DC emitter 2.5 emitter, and we get a 5 volt. So total for the RPM is 2700. So for activity number 2, which we have the variable excited test, so it used as a same as activity number 1. So first of all, we have to on the DC variables. After that, we have to vary the rotor excitation current from 2A to 8A and current to 2A and 8A, and we observe the variation of the AC supply current to the stator current. And then we have to use a clamp meter for AC current measurement, and we have to make sure that the AC current does not exceed 2A. So we know that when AC current is in at ampere, and the motor will stop. So this is the result for table 4 table result. As you can see, the DC current is increasing until 8 ampere, and the AC current is also increasing until 1.2 ampere. So current when is not is zero when the DC current at 8 ampere. It means the motor has stopped when the DC current on 8 ampere. So the AC current is zero. So this is the graph that being plotted. So that's all for my team. Thank you.